All right, this is module 35, prove triangles similar by side, 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 and side angle side, or SSS and SAS. All right, so first thing I have to do, we're going to relate this to something we did in a previous module, which is the side, side, side congruence postulate. The thing that is different with this is that this is the side, side, side similarity postulate. So it's only proving similarity, it's not proving congruence. So we say if the corresponding side lengths of two triangles are proportional, then the triangles are going to be similar. So corresponding side lengths. So if we take JK divided by XY, that's the corresponding side length. KL divided by YZ, that's a corresponding side length, and JL divided by XZ. This is your statement of proportionality here, and this is your statement of similarity. Again, remember your statement of similarity, you have to make sure you have the proper orientation. So once we find out that all of these are the same, so for example, if I were to plug in numbers, I could say that 18 divided by XY is going to be 12. That should be the same as KL, which is 15, divided by YZ, which is 10. That should be the same as 24 divided by 16. And if I simplify all these, I should get 3 over 2, 3 over 2, and 3 over 2, which I do. So if you get the same, that's your ratio, your scale factor, and also helps out with your statement of proportionality. Okay, so here I have is either triangle DEF or triangle GHJ similar to triangle ABC. So we are trying to find out which ones are going to be similar, or which one is going to be similar to triangle ABC. So the thing we have to start off with, again, you look at your orientation. So solution is we're going to compare first triangle ABC and triangle DEF. The corresponding side lengths, again, you can look at the position. AB should be the same as DE, BC the same as EF, and AC should be the same as DF. So when I do that, I do the shortest sides, longest sides, and then the remaining sides. I get the exact same thing. So I can actually stop and say that this triangle, these two triangles are going to be the same. So in terms of similarity. So all the ratios are equal. So that means the triangle ABC, here's your similarity statement, is going to be similar to triangle DEF. Now, in questions like these, I will ask you which one is going to be similar. That means if you find the one, you can stop, and that's it. You don't have to continue on. So, just so you know. Okay? So, but just for sake, let's actually show why the second one or the third one does not work. So, they're not equal, and you say, just for example, you can do one of the corresponding side lengths. So AB's side could be 8 to GH's side, which is 8. That should equal BC's side, which is 12. To similar position of BC would be HJ, which is 10. Immediately I can stop. This is going to evaluate to 1. This will evaluate to 6 over 5, which is not 1. So they're not equal, so they can't be similar. Okay, so it says find the value of x that makes triangle ABC similar to triangle DEF. And this is using the side, side, side similarity. So what I can do is I can set up a proportion using the corresponding side lengths. So first thing I do is I say 4 is to 12. So 4AB, which is the length of 4, is to DE, which is 12. And then I do the exact same thing for x minus 1 and to 18. Now you could have done 8 is to 3x plus 1. It really doesn't matter, but we're just trying to find out the value of x. So once we do that, we cross multiply, make your peanuts, and then solve for the value of x. So the thing you have to do, this step is very important because you want to make sure that you are solving and have found the correct length. So you need to check that the side lengths are in proportion when x is equal to 7. So we say BC's length is going to be 6. DF's length is going to be 24. So you now can check and make sure that all of the lengths are in proportion, which they are. They evaluate to 1/3. So we're good. So this is just basically a check, and you did a lot of this in algebra, and checking is important just to make sure you didn't make any mistakes. So after you do the check and you show, you can say that when x equals 7, the triangles are going to be similar by SSS because all of the ratios are equal and your statement of proportionality. Okay, so we just did side, side, side. Now we have side, angle, side. So remember, this is the included angle. This is one thing I emphasized in a previous module in Unit 4. Included angle. You have two sides and an included angle. The included angle is going to be congruent. The two side lengths are going to be proportional. So, for example, in this one, I have if JK is a ratio of XY, that's equal to JL is a ratio to XZ, so that's your proportion. And we know that J's angle is congruent to X's angle. Then we can say our similarity statement of JKL's triangle is similar to triangle XYZ. Just to show that the numbers actually match up in this numerical example. So we have JK is 20 over XY, which is 12. That should be equal to JL's length, which is 30, to XZ's length, which is 18. And if you simplify this, they're both divisible, let's see, by 4. So that means 5 over 3. The 30 and the 18 are both divisible by 6, so you get 5 over 3. They are the same, so that means that the two sides are in proportion, and you have the included angle that is congruent based off of the labeling. So these two triangles would be similar by side, angle, side. Okay, so I have another example. So it says lean-to shelter. So if you've ever gone camping, maybe you've made one of these. You're building a lean-to shelter starting from a tree branch as shown. Can you construct the right end so it is similar to the left end using the angle measure and lengths shown? So the thing we need to do is to make sure that these two triangles are similar. So what do? First and foremost, you see the corresponding side lengths. AB is to FG is 9 to 6, which is equal to 3 over 2 when you reduce it. So what about the longer sides? So you have AC is to FH, which is 15 is to 10, which is 3 over 2 when you reduce it. So we have the two the two sides give you the same exact number when they are reduced. So far the sides are cool. And the next thing is we know that angle A is congruent to angle F, so the included angles are the same. So automatically, since the lengths of the sides that include angle A and angle F are proportional, you say side angle side similarity theorem says that these two triangles, ABC, is similar to triangle FGH. So, all right. So here it says choose a method, which means you have to kind of look and see and use some information that is given to you and maybe some information that you need to deduce from the actual figure. So it says tell what method you would use to show the triangles are similar. So first thing is you would find the ratios of the lengths of the corresponding sides. So the way you think of it is we have two triangles. We have the smaller one here and then the larger one here. The smaller one has a small side of 9 and a large side of 18. The larger one has a small side of 15 to a large side of 30. So you can say the shorter sides is 9 to 15, which is 3 to 5. The longer sides, which is 18 to 30, which is 3 to 5 again. So far we have two side lengths that are in perfect ratio with each other. The next thing is corresponding side lengths are proportional. The included angles. How are the included angles ACB and DCE congruent? Because of the vertical angles theorem. And this is from a Unit 2 module. So we label that as such. Since we found the two proportions here are equal, or the proportion is equal, 3/5 is to 3/5, we know the vertical angles, which is the included angle, so that means triangle ACB is going to be similar to triangle DCE by side angle side.